Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Camera Tuesday, we're going to talk about video editing, laptops and PC. So let's dive deep into it. Now the primary reason I'm making it, way too many people ask a very silly questions like which computer to buy. Like that's not how it works. So first thing first, when you're talking about video, is generally far larger than what people anticipate or understand. So that's the first point. You have to start with storage. Basically, you rather have a smaller, basically low power CPU and low power GPU than have less storage. You need bonkersly large amount of storage. Now, why is that? Well, video raw files, basically the digital file that goes from your GPU to your display, it's huge. Like it's unbelievably huge. Meaning, when your GPU decodes a file and creates the full data stream and sends it to the system, that uncompressed raw data stream at full HD, not to like 4K or something like that, just full HD at 8-bit color depth, not even like 12-bit or 10-bit, just 8-bit, 444, meaning there is no subsampling, at 30 fps, not like 120 fps. That translates to 186 megabytes per second. That's a lot. And you're like, wait a minute, can't you run 4K Netflix and all that jazz in 20 Mbps or maybe 40 maximum? Yeah, that's the whole point. If you ever paid attention to the markings of HDMI or DisplayPort, the reason why they have like stupid numbers is like 20 Gbps or 40 Gbps is that when you are transmitting data between your GPU and your display, it's full raw, meaning otherwise display will not render it. So for that reason, the data stream is huge. Now again, ideally your sensor will give you that much data. You rather than just you interpreting it, you will get that data from the sensor, but it would be unbearably expensive and so huge that it's not even funny to talk about it. Again, we are talking about 186 megabyte per second, and that's at a 30 fps, let alone 60 or let alone 4K or let alone 10-bit. So fundamentally, we are talking about a bonkers data stream. So how can we have YouTube or TikTok or things of this nature? Well, because compression. Now here still, compression is cool and all for transmission, for delivery, not cool for editing. So how the heck we compress it? Now this is a very critical part. Compression happens in multiple domains. You have to understand each of these domains, otherwise you will not know why the heck video editing files are so huge. First domain is temporal compression, meaning you take the time. For example, if you looked at a film reel, the video out of it is just like every single frame. We call it all eye. All DSLR or mirrorless and some smartphone also have this ability, but generally it's disabled simply because the file size would be bonkersly huge if you store every single frame. Now like, wait a minute, if we do not have every single frame, how the heck the video is working? Well, video is working on what we call GOP, basically the file, that video file that jumps through internet to your computer, that has GOP, meaning there are actual frame. There are like basically three types of frame. You have intra frame, which is actual full frame. Then you have predicted frames, that is just mathematical data. And then you have by predicted frames, which utilizes data in front and data in backwards to render that. Basically in that frame, if you open that frame file up, it will be just a mathematical data file, change this. And that's why computer hates editing on this. Basically, whenever you put a cutting head, if it lands here, it literally has to render 5 frames there, then put that in memory, then bake it, and then allow to you cut it. If you have all eye, cut, no problem. So that's why generally video editing files have to be in all eye. Master file has to be in all eye, never in GOP. Now let that be very clear, GOP could be normal file and all eye would be marked, because again, most of the time, most people cannot afford data cost of this, basically all eye. So most of the time we are dealing with GOP. That's why you can transmit video file over WhatsApp and all that jazz. So this is the first data point of compression. We generally want to shoot in all eye, distribute in GOP, because again, if you directly shoot in GOP, basically your camera itself is shooting in GOP, you will have motion artifact because the data was not there. It's just a mathematical approximation how the pixels changed. So the outcome is never that good. So if you have GOP directly coming from your camera, the computer will consume more power, which you will be odd. It's like, why it's taking more horsepower to compute if the file size is smaller? Because it has to render everything. It will have far more artifacts, far more issues, because it has all that. So you want all eye because it's much easier to edit, and you never want to introduce artifact from the camera itself. You want to do this in your post-processing software, because they are generally far more time consuming. They will take their sweet time, predict a perfect algorithm, then create a render. If it has to be done in real time, so that's why video editing starts with all eye. Again, much huge. You have no idea how huge the file size is unless you start to touch all I. I have full HD coming out of this camera, and I shared once just a cloud photos, but it was in all I format. People were like, why it's 600 megabytes? Like barely few seconds, 600 megabytes. So, and again, it's not raw, just all I. So that's all I. That's the first step. Temporal compression. You want all I editing, and after doing all the cooking and all that, then you want delivery in GOP. So fundamentally, that's the step one. Second, colors. Now, colors is generally have two packaging. Packaging number one is RGB. So whenever you're talking about printers or when you are talking about Photoshop, you will see that if you click the system and go into layers or channels, it will have red, blue, green. But here's the deal. Video does not work that way. Why it does not work that way? It is the wisdom of someone in 1920s and 30s is that when we were jumping from black and white TV to color TV, they wanted two things. First, color data. Second, the basically black and white TV should be able to receive the color signal and still show you a black and white image. So somebody came up with the idea how the heck human eye works. Human eye works on two data principles. First is it has a rod cell, which is the black and white sensor, but that puppy is sensitive, as in like 12,000 ISO. That puppy is sensitive as hell. That's how you can see at night. And then you have cone cells. Cone cells are basically cone. Those have like 3 frequencies, well, red, blue, green. They are very mildly sensitive. So we are not that sensitive in color. We are ludicrously sensitive in motion, ludicrously sensitive in motion and brightness, but not in color. So somebody came up with the idea, instead of having RGB data stream, what if you converted the RGB matrix mathematics? Basically, you have 3 data stream going RGB values. What if you converted the matrix? So matrix conversion went into Luma Chroma. Now, this still has 3 channels. You have Luma channel, and then you have CB and CR channel. Now, these are not RGB channel. While Y channel is a black and white channel, that's the fun part of it. Meaning, when analog TV had to stream color channel, they color channeled it, and the packaging was Y plus CbCr. Meaning, if your old TV will reject the CR and CB data stream, and all you will get is a black and white picture. And when you get a color TV, all they will do is use that data CB and CR data to paint over that. And because our eyes are not sensitive to color variation, it will look indistinguishable. Now again, let them be clear. Is it scientifically indistinguishable? Hell no. It's a compressing system, but it does work more than good enough. So this is a system right now how every video file works. It started with analog system, but because the principle was sound, we just use it and call it chroma subsampling. We do the same thing. Your sensor creates RGB data, but video file does not have RGB data. Video file has this data, basically Luma and chroma data. Again, let that be clear. There are some file formats that can give you RGB video. Generally, we do not use that. It would be huge. So what's the trick? All you did is like have 3 channels of data converted into 3 other channels. What's the point? Well, point is color data is now independent of brightness data. You save the brightness data 1-to-1. You do not touch that data package. But in color data, you compress the hell out of it. Meaning 444, you do not touch it. It's just like different packaging. You send it, no effect. 4:2, you compress the data of color channel by 2 pixels, meaning instead of 2 pixels having 2 independent values, just like let's average them out and just go YOLO it. So you halve the color data and the output looks more or less the same. And then you have 420, just like how your YouTube transmits that. So you have luminance, looks exactly the same. And then you have chroma, that is barely 25% at this point in time. You have compressed the color channels, basically CB and CR data, to 25%. So file size is bonkersly small. But because it's think in this way, it's like there is a black and white painting and then you paint color on top of it, but the color resolution is much lower. So instead of RGB where all 3 are balanced, here it's like you have luminance, which is like full resolution, and then you have compressed resolution in color. Looks almost indistinguishable. That's why we use it. So 420. Now 420 is awesome for delivery, but you never want your green screen data to 420. Again, green color would be messed up. So fundamentally, you want to shoot your master file in 444, not in 422 or 420. So that's the whole point. And CB data and CR data is different compared to RGB data. RGB data is 0 to 255, I think. Basically 0 to 8-bit. But here it's negative value, meaning it would be minus 120 to plus 120, something like that. So it takes one value in one axis, another value in another axis. Combining both of them creates the RGB data that your graphics card sends into your GPU. Yeah, matrix operation. Mathematics. They were smoking something good in 1930s when they come up with this idea. Good stuff. So that's the color compression. So you had temporal compression and now you have color compression, and this still is not good enough. You can still find your DSLR files to be huge. Why? Even though it would be generally at 4:2, generally it would be all I, it still would be small. Why? Because your frame compression is not huge. Frame compression is the data layer compression, meaning now you are actually compressing it. So far it was like, it does not make a difference at 24 frames per second. Persistent of vision is like not really beneficial to have that many frames. It's like, throw away some frames, convert it. But color, same thing, throw away, it does not matter. But now you have to compress it so you can actually transmit it. So you basically take the frame, convert into mathematics. When you hear about H.264, H.265, AV1, VP9, those things are taking the frame, compressing the frame itself. That's why you generally do not want to use compressed formats for video editing. It will destroy your CPU. The CPU is like, I have to redraw every frame. So these are the three layers of compression. So first compression, all I to GOP. All I is better, but again, file size is heavy. Then you have RGB conversion into luma and chrominance. Color channel would be compromised. Try to shoot in 4:4:4, if not 4:2:2. Do not go 4:2:0 if you have to do green screening and all that. And because again, the color channel would be compromised. So, and you have to inherently understand that that's why people want to focus on contrast so much in video recording. If you have good contrast, the luminance data would be safeguarded and you will get good output. And then you have spatial compression, like actually how big the frame is. Raw frames would be huge, so we generally don't do that. So that's why, let that be very clear. Whenever you are touching actual video editing processing, storage, just shut up, buy as much as you can. Like if you have a laptop, try to buy some laptop that has at least 2 M.2 slots, so you can populate them with like big points, or have an external NAS unit. Otherwise you will be shocked how quickly hard drive runs out, like shocked. Now we understand the core aspect of the file size huge. That's full HD. When you are talking about today, like nowadays, yeah, most computer cannot touch it. Like even high-end ones will have hard time dealing with full resolution raw uncompressed editing master files, what way cinema calls masters. So masters are generally what we call a DCI 4K. So whenever you're looking at like, oh, this picture is shot in 12K or 8K or not. Most movies, or almost 100% of the movies, unless it's made for Las Vegas Sphere, almost all of them are rendered at 4K. So DCI 4K, and again, that's a very recent thing. Till like 2010 or I think 2015, most was still at 2K, which was like 4K full HD, just a bit wider. So that is the master file. This is where the actual movie is made. So 4K 4:4:4, again no color subsampling, and at 12-bit. Now again, 12-bit nowadays is not that great. Nowadays if you are shooting Avengers or Endgame, yeah, those puppies have so much VFX, is like, bro, go up to 14 or even 16-bit. So let's give you a simple example. You have DCI 4K master file, which is 4:4:4, no color subsampling, 12-bit, so you have some gradation, so you can do HDR master, and then you have 24 frames per second. That puppy grosses to 911 megabytes per second. How big is that? Well, here's the deal. Mechanical hard drive. Basically, when Avatar is being shot, if Avatar had to be edited at that point, there was no mechanical hard drive that can dump data. So they would have to have a server and optical connection going from the server to the editor's computer. Only then they could be able to scrub. And if they have multiple video files, stacked in the timeline, yeah, lol, it's not gonna work. So like, okay, then how the heck they do it? Proxy file. No one is stupid enough to do mastering directly on the master file itself. So proxy file is either recorded. Many cameras have this ability to do proxy recording, meaning you will have one massive multi-gigabyte file and then you'll have small 500 megabyte file. Generally, they are still all I, but the frames are compressed, colors are squashed like hell, and it's just there for editing. So proxy file, either it can be recorded in camera or it can be done in post. So if you have not recorded it, it's not an issue. All software, major software generally do that, be it Adobe or be it, what was another? DaVinci Resolve. All of them have the ability to render these files, basically proxy files. And proxy files have basically a video layer that has metadata frame by frame. Basically, if you do any editing, it's like my cut is here, it knows frame number 75 is the last frame. It will call the only till frame number 75 into master file. So you do all the editing, all the timeline editing you see, that will always be done in proxy file. Once you're done with that, proxy file is done, then you will click render. Now here's the deal. Render will slowly go into the memory and start replacing the proxy frame with a real frame. and tada, that you will get full high quality video output of it. It's a very cost effective. You do not need like high end Threadripper computer or like, you know, bonkers computer, and it's less frustrating because you can actually move the playhead. And let that be very clear, it does not matter how high end your graphics card is. The moment you have 2-3 streams, even Linus Tech Tips computer which have Threadripper and Red's official camera, the playhead is still like, bro, I can't deal with this, because it's not meant to be. Nobody was designing the DCI master files for that thing. It's like, nah bro, no, you built proxy file, you go YOLO on proxy files. Again, let that be clear, that's for master files. Generally your YouTube will not be dealing with master files. You're basically, if you're dealing with someone's wedding footage, it's unlikely that you are shooting in 12-bit or something like that. Most likely at best it will be 4K 10 bits and 444 if you are really flexing, 4:2 if you are like okay-ish enough, and frame rate could be higher, 60, and then the master file will stretch to 24 for cinematic look. So that's the whole point. And again, even laptops can manage complex edit if you have proxy file, and you generally do not travel with your laptop that has the master file, you travel with proxy file. So, and again, it's a security benefit also. So even if somebody steals your laptop, they can see how the scene looks. They can't see the film, they can't leak the footage. It will be like 480p file. So proxy file, that's how all the editors work. Do not ever think like, okay, how high horsepower computer I need to directly edit it. No, you don't. And again, that's why if somebody smokes and tells you, oh, you know, Oppenheimer was shot in like 12K IMAX. No, the IMAX was scanned. It was scanned at that sort of stupid resolution, 12K, but the master file was still 4K. And after the master file has been done, like cooked and edited, then it was using laser, it was encased into that film. Yeah, it's 4K. Don't smoke an orgasm over like, oh, 12K. And anybody says 12K on lens, bitch slap them. Unless the sensor is this big, yes, not happening. You need reflection to do that kind of resolution. Look into James Webb Space Telescope. There is not a single lens into it. Nothing, not mirror sensor. There is no lens. You do not put lens. If light has to go through a material, it will be contorted. Physics does not like that. So proxy file is the first point of thing. And again, do not go 8K, 12K, nah. Even now, 4K, enough. But again, 4K DCI, that has like full no chroma subsembly, bit depths are generally huge, and FPS, again, depending on your project. Most projects are still at 24. Now we come to color grading. Now, generally, editors have the benefit of working on proxy file, but the colorist does not have that benefit. There are some things that require full frame size, aka VFX, green screen, color grading, and again, now you understand why these things require VFX studios. So fundamentally, and be mindful. Whenever you're talking about these sort of things, especially colorist, you are talking about display, high quality display. You cannot cheap out on that. Like you have to have high quality display. Basically, there are people who are doing actually like pro level cinema mastering, like Dune, Blade Runner, or even Oppenheimer. They will generally have a miniature theater just for color correction. And not joking, that's normal. So you will have a very cinema grade display which is verified by some company that will keep checking it every, I think, 6 months, where they'll like look into it and calibrate it, and they'll have a digital cinema projector. And you're like, why do you need projector? Projector behaves differently, and you are making a master file for theaters. So theaters, you have to know how it looks in theater. So fundamentally, they will have that. And even if you are talking about like a small scale, like Netflix only, they will still have this monitor. They may not have the projector setup. They'll have a monitor and they'll have a TV, big high-end TV that is calibrated. So you cannot cheap out on that. Like flat out, that's the one painful part of colorist. Like unless your display is good, you do not know how the color is supposed to look. So that part is expensive. You can't cheap out on that. And generally, okay, how the heck they will do the coloring? Well, they generally deal with one frame at a time. As in, you have footage, like let's say there were 60 shots taken. They will take out like, okay, this batch of shot, okay, put that into the system, and it's like, okay, take or adjust and all that, and then just keep tweaking it. They do not like, you know, slice, cut or anything, just like the, you know, clip number 1, edit, done. Clip number 2, edit, done. Clip number 3, edit, done. Or if it's a one-man team, after the proxy file would be done, after it's a render, then they will be like, okay, now I have one data stream, much easier, I'm not cutting or any, tampering with it, and then you color correct it. So generally cinemas work in what we call divide and conquer or parallel process. So generally the moment capture shot has been done, it will start to go to your editor and it will start to go to your colorist at the same time. So proxy file to the editor and the master file to the colorist. Colorist will start to color it based on the look and feel, convert the log file into some sort of color, like precursor color, and then they're gonna keep cooking it. So cooking generally can be done in 2 times. So first you take the clips from log file to color file, and then color file to the final color grading after the editing has been done. So you can give a how does it flow and all that. So generally both of them can work both times. So timeline, basically how the movie storytelling happens, that's the editor's job. And colorist's job is how does it look. Basically, if you look into like matrix, it looks all the green and it has like a different kind of tone to it. Like you look at a matrix frame, you know it's a matrix frame. How? Because of the colorist. So you look into Dark Knight Returns and like it has a different kind of grunge to it. That's a colorist job. You look into basically Zack Snyder's frames, it has that noise and like to it. Colorist job. So both generally work at the same time. So this place you cannot cheap out. You cannot. And again, this is another reason why Apple was very smart when they actually started to make their laptops. They did not cheap out on display. They actually had good quality display. That's why generally video editors are like, Apple laptops. Because while Windows does have good laptops, oh my god, they generally try to cheap out on weird things. Webcam, poop. Display, who needs display? I'm like, dude, that's the first thing. Good display. So, but again, let that be very clear. Whenever you're talking about something like this, you have to have pro grade display. And pro grade, not Apple pro grade. Pro grade, like whose price is so expensive that Ferrari looks cheap. Now let's understand the most important part, cost. Now, we all want everything for free, okay? You want it, I want it, every Tom, Dick and Harry wants it. Like, what if I have like, Linus Tech Tips, like, 64 core processor, like 2 terabytes of RAM, and then a 8K render engine from Red, and then this and that. It's like, yeah, we all want everything. It's just that we don't have money. And again, here's the funny part. If you have money, you have to spend it wisely. So fundamentally, you have to plan accordingly, meaning would it be better for your workflow to have a NAS that has much higher data throughput so a lot of people can work on it, like colorist and editor can work at the same time, or it would be better to just have like one high power computer? What would it be? You have to balance it. Money is always limited. Even if you are talking about like Avatar, they will still have some technician whose job would be how do we optimize the money, because again, if you have the money does not mean his problem solved. It's just like where the money would go. Because if I'm not mistaken, I think Avatar master file was, because it's so VFX heavy, it was like Avatar 1 I'm talking, I think it was 1.5 petabyte or something. Bonkers. So you have to plan accordingly. They cannot afford to give every editor the latest and greatest. They're like, okay, you work with the best, but again, they will make sure the colorist have good what we call display, and the editors have like quick proxy files so they can start working ASAP. And again, in their scenario, editors were not that important. It was VFX artists. They're like, yeah, we're gonna render it and you're gonna sit down and we're gonna have a chill. We're just gonna chill. So, and one of the most common mistakes that every Tom, Dick and Harry does who's asking it is just like, oh, which laptop to buy? That's not the question. Question is, what application do you use? Do you use Adobe Premiere, or do you use DaVinci Resolve, or do you use something else? And the moment you know that, like, this is my software package, look into it. Does it run better on Intel or does it run better on AMD? There are people whose sole job it is to make basically benchmark regarding every software. You can easily find it based on the hardware available. That's how you figure out, do I buy AMD? Do I buy Intel? Do I buy NVIDIA? That directly goes into the software package, not on what you desire. Does the software package work well? And again, they will tell you, there's so many awesome channels for this. You put a little bit of effort and you're like, okay, this software, do not put more than 32 gigs of RAM. It does not utilize it. Or put as much RAM as you can, but do not put a high speed RAM because it does not benefit, but have large amount of RAM. You have to know your software. So fundamentally, without it, you will not have compatibility and you will waste money. So that is a very critical thing. And you have to learn how to work effectively, aka learn proxy files, rather than just like, what if I buy the highest and latest and greatest? No, don't waste time on that. So learn how to work effectively. Pipelines, proxy files, file management, all of that will make your life much better rather than a high-end computer. And then color critical work does require good display. Let that be very clear. That part you cannot cheap out. You cannot cheap out on sloppy display, so to say. Sloppy display, output would be sloppy. So that's how cost is supposed to be worked. So this was my presentation on basically what kind of computer and data set we are dealing with. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me excitement. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.